Anchor installation for manufactured homes need not be a complicated procedure. However, there are certain steps that an installer must follow in order to ensure that the homeowner has adequate windstorm protection. Tie-Down Engineering has worked with manufacturers, installers, and government agencies to bring you the first in a series of videos for the proper installation of anchors and the accessories required to complete a home installation. Our testing in 11 states has shown us that anchors must be used properly, or they will not provide the holding power required by HUD, state, and local agencies. Currently, there are many different anchors certified for use in anchoring homes. Ground anchors range in size from 30 to 60 inches long with single and double helixes. The helixes are 4 to 7 inches in diameter. Plus, there are several specialty anchors for rock and concrete applications. Before you start any home installation, be sure to check with local officials for the requirements in your area. Anchors derive their holding power from the ground they are installed in. This is referred to as the cone of influence. The cone starts at the helix and expands up and out at approximately a 45-degree angle. The cone for a 30-inch anchor contains 19.85 cubic feet, or 2,400 pounds of soil at 122 pounds per cubic foot. Obviously, for the shorter anchor to reach the required 4,750 pounds of holding power, it must be installed in hard-packed Class II soils. The 48-inch anchor has a cone of 80 cubic feet and the potential of 9,800 pounds of holding power. However, in loose soil conditions, the anchor can still lose its grip as the soil breaks away much easier. In all our travels, the most common installation error we see is the use of these smaller anchors in medium to loose soils that require a longer anchor. The soil test probe is used to determine the soil class and proper anchor for your home setup. The test should be conducted in the area you plan to install your earth anchors.
Using the torque probe, you'll see the relationship on the anchors. You have a 30-inch anchor and a 48-inch anchor standing next to the torque probe rod. The torque probe will go down into the ground 30 inches so that it can take a reading at that depth, and then if you're hitting a soft soil condition, of course, you'll have to go down further for a 48-inch anchor, and you can see how much of the torque probe will be sticking out of the ground when we are using that 48-inch anchor. Okay, the torque probe consists of the long rod we just installed and a torque wrench and a torque adapter. You attach the torque adapter plate to the torque wrench. Then this will be used on top of the rod that we installed into the ground, and in this case it was 30 inches to show the torque compression that we have at that depth. Okay, the torque probe is then turned in a clockwise direction over the rod and taking a reading, with the highest reading being wherever the rod starts to turn. Okay, what kind of reading do you have on this, Jim?
Like right at 150.
After finding the value on your torque wrench, use the soil classification chart to determine the soil class and proper anchor. A reading of 550 inch-pounds and above describes a Class II soil. A 30-inch anchor with twin 4-inch helixes is a common anchor for this installation. Class III soils have a reading of 350 to 550 pounds. A 48-inch anchor with a 6-inch helix is the most common anchor used in this soil. A reading of 276 to 350 inch-pounds is classified as 4A soil. A 48-inch anchor is required in this soil, and additional requirements may apply in the number of anchors used. Class 4B soils have a reading of 175 to 275 inch-pounds. Some states require a 60-inch anchor with a 7-inch helix. Remember, below these values, a professional engineer should be consulted before any installation begins. Anchors need to be properly installed to provide the holding power required. The 45-degree or inline method is commonly thought to be the strongest of the installation methods. However, two conditions must be met to provide the holding power required. One is that the anchor must be in line with the strap being attached to the home. That is, the helix is directed away from the home, and this usually requires that the anchor be installed before setting the home. The second condition is the use of an anchor longer than the soil test probe chart has indicated for your installation. When the anchor is set at a 45-degree angle, it loses part of the cone of influence used to hold the anchor. A common error in anchor installation is leaving the anchor head above ground level. Tests have shown that the anchor will fail at less than 700 pounds of side load. When tension is applied, the rod simply bends over, causing the home to fall off the foundation. An anchor is never to be left in this position. Even with the anchor head installed flush with the ground, the anchor cannot provide adequate holding power. While the helix will do its job of holding the bottom of the anchor in place, the thin rod will knife through the soil or bend as tension is applied. Anchors require some form of stabilization to be effective. Using a stabilizer plate does not add to the holding power if the anchor is left above ground level. The rod has room to bend over the plate, allowing failure in the system. The proper way to install an anchor is with the stabilizer plate and anchor head flush with the ground level. We will cover this in greater detail in a few moments. While we are discussing ground anchors, it should be pointed out that the cross-drive or rock anchors are not designed for hard soil or rocky conditions. These anchors are designed to be used in solid rock. When used in hard or rocky soils, the rods will bend with less than 700 pounds of side load or 1,000 pounds of direct load, a far cry from the 4,750 pounds of holding power required. As discussed earlier, anchors must be stabilized to keep the anchor rod from bending or knifing through the soil. The most common anchor stabilizer is the steel stabilizer plate. Anchors can also be installed in line and must be of sufficient length to hold 4,750 pounds. A concrete collar measuring 12 inches by 12 inches by 18 inches can also be used to stabilize the anchor. The proper installation of an anchor starts with the setting of the anchor at a slight back angle from the home. The anchor is installed, leaving 15 to 18 inches of the anchor exposed. The stabilizer plate is now installed with no angle, slightly in front of the anchor. The anchor is now installed the remainder of the way into the ground. Using the slotted bolt and strap, pre-tension the anchor until the anchor rod is flush with the stabilizer plate. Strap that meets the ASTM specifications for stretch and breaking strength is the only approved strap for manufactured home installation. When using a frame tie, the hook or buckle must start on the upper inside corner of the I-beam. The strap is then brought around the frame and over the strap on top of the I-beam and down to the anchor. The strap should always come from the top of the frame to reduce flexing of the I-beam. To attach the strap to the anchor, pull the strap past the anchor by about 10 inches. Cut with snips and feed the end of the strap through the slotted bolt. Using a ratchet wrench, wind the strap around the slotted bolt. The strap must wind around the bolt at least 5 times to provide proper holding power. Continue to wind the strap, pulling the anchor head flush with the stabilizer plate. This gives the system the proper pre-tensioning required for holding power. A side load of 700 pounds on a home directs a vectored load of 1,000 pounds on the strap and anchor when installed at a 45-degree angle. As the angle increases, so does the force on the strap and anchor. At 53 degrees, the 700-pound side load translates to over 1,100 pounds, and when installed at 60 degrees, the direct load doubles. This increased vectored force is the reason we recommend that you need to stay at a 45-degree or less angle with your strap installation. In this animation, the wind applies side load pressure to the left side of the home. The anchor on the left or windward side does all of the work, and the strap on the right side of the home goes slack. When any of the installation guidelines are not followed, the home is put at risk in sliding off of the foundation blocks and causing severe damage to the home. When the anchor moves over 3 inches, the blocks tilt and slide apart. Tests done at tie-down engineering show the tilting of the blocks prior to sliding apart. In the tests conducted by tie-down engineering, we use specially built trailers to duplicate a home installation. Using load cells, dynamometers, and simple measuring tools, we can determine when and why anchors fail. Tie-down engineering currently uses 4 portable test rigs. The anchors are tested in a variety of soil conditions in different states. Stabilizer plates, straps, and accessories are tested in real-world situations.